Hi, this is Jashwant Reddy. Today my topic is importance of stacks and its properties. The stack, your digital building blocks, a fundamental data structure built on a simple yet powerful idea, and one of the most important tool in a program's toolkit. What is a stack? A stack is an inner data structure that follows the LIFO principle. Last in, first out. Think of a stack of plates. You can only add or remove for the top. The last plate placed is the first one removed. Why do we need stacks? Back, undo, and redo. Every act is pushed onto a stack. Undo pops the last act. Simple and elegant. Function calls. Program use a call stack to stack with function is remove and where to return. Browser navigation. A black button pops the current page. Remove the trivial URL for the stack. Explorer processing. Complaints and calculates use stack to evaluate mathematical expressions. Key properties. Push and pop. Core operations, utility operations, stack interface, state queries. Push, add into the top, pop, remove it from top. Peek, view top without removing, is empty. Size, stack state. These two operations are the hit of every stack. Both run in control time, reducing of stack size together with peek is empty and size the complaint stack interface. Push adding element to the top. How it works. Push place a new element on the top of the stack. A stack grows upward with each operation. Time complexity 0 to 1. Space complexity 0 to 1. Top pointer intercement of each push. In array based stack, what the stack overflow with the complexity is reached. Pop removing elements for the top. How it works. Pop removing and returns the topmost elements. The stack shaking and the pointer moves down. Time complexity 0 to 1. Always remove the most recently added item. Calling pop on an empty stack cases underflow. Always check is empty. Before popping, they avoid runtime error and circular operations. Peek reads the top elements without removing it. Strictly for interspring states safely. Is empty. Returns true if the stack has no elements. A grid before pop or peak operations. Size returns the number of elements currently in the stack using full iterate and budding. Common implementations. Array versus linked list. Array based stacks, fixed or dynamic arrays 0 to 1. Push pop very fast. Memory effectivity. Risk of overflow is fixed size. Best for no size workloads. Linked list stack. Nodes link versus pointers 0 to 1 push pop. Equal fast. Truly dynamic, no overflow. Extra memory for pointers. Best way size is unpredictable. Both achieves 0 to 1 for the core operations. Choose based on memory considerations of flexibility needs. Practical examinations and acts. Functions call stacks. Every function call is pushed auto to call stack. when it returns it's a proper pop. This is how reads works. Each call adds a new frame until the base case triggers and wedding. Undo, redo features. Text editors maintain two stacks, one for undo and the one for redo. Each edit is pushed. Undo pops under reverse. Redo pushes the resolve back. Summary and best practices. Now your LIFO. Always resolve about stacks in terms of list in first out. It is simplifying problem solving. Choose the right implementations. Using arrays for speed and locates. Use linked list for unbounded growth. Grounded against edge cases. Always call is empty before pop or peak to prevent underflow errors. Stack solving specific problems. Reach for a stack when you need back taking neurons of reversals, not for random access. Thank you.